interesting projects. In this video, we are going to explain about project titled Child Attention Detection through Facial Expression Recognition using SVM Algorithm. The main objective of this project is to detect the child attention by utilizing the facial expression recognition and the SVM algorithm. The focus is on analyzing the facial features and expressions to determine the level of attentiveness in the children. Although the original implementation involves real-time detection using a webcam, this project instead focuses on predicting the attention from the images and videos. The training of SVM algorithm is performed using the child affective facial expression dataset, which contains the various facial expressions associated with different attention levels. By averaging this dataset, accurate recognition of attention-related facial expressions can be achieved. The project aim is to detect the child attention by examining the facial expression using the SVM algorithm and to create a system that can accurately identify and categorize the various facial expressions linked to different levels of attention in the children. And by analyzing the facial features and expression, the model can effectively recognize and predict the child attention and offering the valuable insight into the child behavior and facilitating the attention monitoring. These are the basic requirements that are needed to build this project. Hardware requirements are operating system as Windows, processor of i5 and above, RAM of 4 GB and above, hard disk of 20 GB and above. Software requirement Python IDEL with version of 3.7. These are the modules that are developed to implement this project. The first module is load and pre-process the dataset. In this module, the child affective facial expression dataset is loaded. This dataset contains the images of children exhibiting the various facial expressions such as anger, disgust, fear, happiness, neutral, sadness, and surprise. The dataset is prepared for further processing by applying the pre-processing techniques. This includes of normalization, which ensure that images have consistent scale and range values. Additionally, feature extraction is performed using the principal component analysis algorithm. This step aims to identify and extract the most significant features from the images and reducing their dimensionality. And the second module is train SVM algorithm. In this module, the support vector mission algorithm is trained using the pre-processed and feature extracted dataset. The dataset is split into the training part and the testing part. Of 80% of dataset is per training and 20% of dataset is per testing, and the training set is used to train the SVM model. The SVM algorithm learns from the training data to identify the pattern and relationship between the facial expression and the child attention. And the third module is predict the child attention from image. This module focuses on predicting the child attention from the single image. The trainer SVM model is applied to image by extracting the features and feeding them into the model. The SVM model then predicts the level of attention based on the child facial expression in the image. And the final module is predict the child attention from the video. This module extends the prediction to a video sequence rather than of the single image. The SVM model is applied to the consecutive frames of the video to track and predict the change in the child attention over the time. The facial expression in each frame are analyzed, features are extracted, and attention level are predicted using the SVM model. Execution of this project. To execute the project, first we need to open the code folder. This is the code folder consisting of different files. The first one, input images, is the dataset we used in this project, that is the different images of the child. And the videos, these are the video dataset which is used for testing the model. And the main is an Python code file, and the model is consisting of .npy file which can be loaded into the project code during the runtime to utilize the trained model for various tasks such as making predictions on new data or performing the specific operations. and this is the run.bat file. Instead of executing the program in command line interface, we created the Windows bat file to execute the project. Now to run the project, double click on run.bat file. This is the graphical user interface. With this, we are interacting with the program. Now click on load and pre-process the dataset. Using this, we are uploading the dataset and pre-processing it. Here, the total number of images found in the dataset is of 28726 and the total classes that are found in the dataset is of angry, disgusted, fearful, happy, neutral, sad and surprised. And then click on Try an SVM Algorithm button. By this, the SVM algorithm model is generated with the pre-processed dataset. It takes some little amount of time due to the images count is of huge one. Here the SVM prediction accuracy gives of 99.38%, and then click on predict child attention from image button. Here we need to select any one of the image from the input images dataset, and here I am selecting of 10th image and click on open button. Here the child attention detected as angry, and then close this image and then click on predict the child attention from video. Here we need to select any one video from the videos folder and then click on open button. Here it consists of sequence frames of images and detecting as of sad, fearful, sad, happy, happy, sad. In this way, we can detect the child attention. In conclusion, this project successfully addresses the objective of detecting the child attention through the facial expression recognition using the SVM algorithm. By analyzing the facial features and expressions, the system can accurately identify and classify the different levels of attention in the children. The use of child affective facial expression set and the training of the SVM model enable the effective prediction of the child attention based on the facial cues. This project contributes to the field of the child behavior analysis and provides a valuable tool for attention monitoring in various settings.
For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.